Alright, so we're going to look at completing the square now. I've given us this as our example, and we're going to use one initially where I know the answer because I want it to be a little bit more clear. So my A value here is 1, my B value is, and my C value is. Now the really important value we're completing the square is my B value. So what I'm going to do is I want to create a bracket whereby I've got So the reason I'm doing this, right, I've added, that's my original expression, I've added the red terms in. Now 9 was not selected randomly. Does anyone know how I got 9? Sorry, I don't know what that square is. Half 6 and square it, very good. So my next line of working this part here has become that. Now I can't just add 9 into my expression, can I? So I've added 9 and subtracted 9. Now the reason I picked 9 is because, as Beth said, it's half of that square. Not Beth, that's bad, Sylvie, sorry. Half of 9, half of 6 squared is 9. Sweet? That then becomes this. Now I could expand that to prove that becomes the same thing, and I might just do that just to prove that this works. So I get x minus 3, x minus 3, x squared minus 3x plus 9, x squared minus 6x plus 9. Are we happy with that? That is equivalent to that there. Good. What am I left with? X minus 3 squared minus 4. What have I done? Put it in a turning point form. You could sketch that really quickly. You could sketch that, I reckon, in 2 seconds now. So do that. Go ahead and sketch that for me. So that's essentially our completing the square. Now, I'm going to talk about some scenarios where we've got different values, but that, in a nutshell, is completing the square. What I do is I add a b on 2 squared component. Why do I do that? Because I know my next step is going to be this, but I can't just add a b on 2 squared. What do I have to do? Minus a b on 2 squared. I then treat these parts separately. No, I don't want to do that. That looks awful. I treat this part here separately. Where's my green pen? I treat this part separately, and I treat the first part separately, and I'm left with the bottom line, which is in turning point form. Are we happy with that? Does that make a bit of sense? We are going to go through another example, but I might get you to do your own one. Do you want another example, or you want to do your own? Another example. It is a complex technique. Yep. I'll talk about the non-monic scenario. It works for all types of quadratics, but there's a bit of manipulation you've got to do first. And it can make the maths quite gross. So, I'm going to give you guys a head start. The function I want you to solve for, again, it's really nice that we've got functions that are a bit grosser. So we're going to go x squared plus 7x plus 8. So the function we're solving is x squared plus 7x plus 8. I want you to use completing the square for that.